Good afternoon. Wow, that was awesome. Good afternoon.
Good afternoon.
Thank you. My name is Jim Yannick. I'm a senior systems engineer with VMware.
Hi, Jimmy.
All right. Today's session is euc2103. It's storage tips regarding VMware View environment. I'm a systems engineer with VMware based up in Minneapolis. I'm also an end-user computing specialist. I've been with VMware for about 3.5 years now. Prior to that, I was with a company called Altiris. Did a lot on the desktop management side. And prior to that, was with Dell in the storage and server space. My co-presenter is Jeff Whitman, who I'll let introduce himself.
Hi, I'm Jeff Whitman. I'm with VMware. I'm a core SE, but I've been a desktop specialist, a subject matter expert for my 4 years at VMware. I'm also based in Minneapolis, like Jim.
Any Minneapolis people in the audience? Great. Good to see the hometown crowd. Couple things just to mention. We like interaction. So we're going to be interacting with each other during the course of the presentation. We invite questions. What we're going to try to do, since it's a big room, is the one of us who's not talking, we're going to try to sort of be halfway through the room. So if you've got a question, raise your hands. I'm going to be a little bit of the question police so that we stay on time. We have a solid hour. We want to finish on time. We'll stay as long as you want afterwards to answer questions as well. So if you want to have conversations afterwards, neither Jeff or I have to be anywhere till 2 o'clock. So we want to make sure you get a good session and get your questions answered. So the name of our session is Storage Tips and Best Practices, VMware View Deployments, or How to Plausibly Blame the Storage Team for Your View Woes. So we have to have a subtitle for the session. This is the disclaimer slide. I'm guessing you've seen it once or twice. Any forward-looking statements we make are just that, forward-looking statements. So here's our agenda. We're going to talk about the problem. One of the reasons we have this session is Jeff and I, in our interactions with customers, have seen the same thing over and over and over again, and that's where storage isn't architected properly for a View environment. So we're going to talk about the problem, how to understand desktop I/O requirements. We're going to hit assessments pretty hard, and if you don't know what that means, you will by the time you leave here. And then we're going to talk about some of the solutions to the problem. A couple of shout-outs here. I want to just... we've had a few people who helped a lot with this. Andre Levovich, who's sitting here in the second row from myvirtualcloud.net, probably the best blog out there on desktop subjects. So if you haven't been to that site, please go there. Andre's helped review the deck for us. Ryan Sacente Cinco Grendal, he's VCDX number 65. He actually helped us, and his employer DataLink was kind enough to provide some storage that we could do some testing on for the course of this. Matt Eccleston, who reviewed our deck, and also just some help from the local EMC NetApp teams, as well as Lakeside Software, who provided some of the assessment data that you'll see here. A couple of disclaimers. First of all, don't be offended if you represent a storage company or you have favorite storage if we didn't mention your stuff. We're just using it for examples. Don't stalk us about your stuff. Last year we did a thin client session, and we had thin client vendors tackling us and coming up to us at 2 in the morning when we'd been drinking, and we'll be out on the solution floor, and we'll get a good chance to see everything. There's a lot of really great storage solutions available. You may own or represent one of these companies. If we missed you, sorry. Also, we're primarily talking about linked clones here. A lot of what we're talking about also apply to full clones, but you'll see some linked clone specific things that we'll talk about here. If you don't know about linked clones or View Composer, shameless plug for our session from VMworld 2010 where we did a deep dive on View Composer. All examples are just that. Your mileage may vary. And this is a 1-hour presentation, not an exhaustive storage symposium, so we're not going to get too far down into the weeds. So first of all, it isn't rocket science, okay?
By the way, the picture there, Jim actually went to Florida for the last launch of the space shuttle, so that picture was actually taken by Jim in Florida. So,
yeah. A little bit of a space nerd. So, yeah. So again, it's not rocket science, but it might be model rocket science, okay? So you do need to apply some information to this. You do need to look at this pretty carefully. So again, we're going to talk about the problem first. What's the problem we're trying to address here? That's you.
Okay, and again, if we have some difficulty with transitions here, this is the first time we've done this together, so we'll stumble through it. So the problem is that we find is most people think about storage in terms of capacity, right? That's especially true when we start dealing with the VMware team and the desktop team and management, right? The storage team might think of storage in terms of performance, but from the VMware side, we never really get ourselves into problems. The VMware team goes to the storage team, hey, can you carve me out a LUN for the VMware environment? They present it, and then the desktop team consumes it, right? Because in the server space, we don't really ever have problems with terms of running out of I/O in general, right? Until we start getting to more mission-critical applications. And I think that that's one of the biggest misconceptions out there is people think, oh, I've already virtualized servers. Virtualizing desktops is going to be easy. And the opposite is true. It's much, much more difficult to architect the storage backend for a virtual desktop environment just because of the variables that we're going to get in today. So I think that's the big problem here. So you need to stop thinking about storage from in terms of capacity and think about it in terms of performance, right? Because after all, size doesn't matter, with the exception of if we start to do SSD and look at SSD exclusive solutions, we can run into capacity issues there just because of they deliver a lot of I/O, but generally we're at a smaller amount of capacity. Implementing with a poor architecture is really hard to correct later. That's an important one, right? When we actually go to implement or to architect these virtual desktop solutions, we really want to make sure we get it right the first time because we really need a good end user experience, right? Generally, when we do a virtual desktop deployment, if the first one doesn't turn out well, it's a lot harder to go back and ask to do another virtual desktop environment, right? So we need to make sure that those end users experience at least as good a performance in the virtual desktop than they had in that physical desktop space.
In fact, if you deliver a bad desktop experience to your CIO, you may not get funding for any more projects you want to do.
Okay, so desktop I/O. So who in the room knows what the average and peak IOPS are in their physical desktop environment? Can I see a show of hands? Okay, for you guys, you are a geek. You're the one, right? In general, nobody knows this, right? And the reason that nobody knows this is in the physical desktop world, I/O generally isn't a relevant thing to discuss, right? Each physical PC has a spindle, it has a local hard drive, and there's not much we can do about this, right? Whatever performance it delivers, right? So the big difference here is when we move into a virtual desktop environment, it's extremely important to understand what that I/O footprint looks like, because now when we move to shared storage, we have all the users sharing that same disk back in. So we really, really need to understand this, right? This is a big thing. So just a couple terms to kick things off. Minimum guaranteed IOPS, right? So what we're talking about here is basically understanding the total IOPS available by the physical spindles that sit underneath your data store, right? And again, that number changes dramatically based on what type of drives you're using in that data store. So for example, if I'm using 15K SAS drives, if I had a data store with 10 of those, and each 15K drive, if it gets 175 IOPS, I would know that I have 1,750 IOPS available from that data store, right? So now if I look at this, and again, I'm trying to simplify things. I know that depending on architecture, this can be much more complicated, but in simplified terms, I'd have 1,750 IOPS in that data store. So if I had 175 users, I would know that in a worst case environment, I'm getting 10 IOPS on average per user, right? So it's a theoretical worst case. Now, maximum available IOPS is the opposite. It's saying I've got 1,750 IOPS, and if I only had one theoretical user using it, he would have 1,750 IOPS available to his desktop, right? So what we like to talk about is average IOPS. And ideally, we want to talk about average IOPS that's empirically observed, where we've actually looked at the physical desktops in your environment, and we understand what that average IOP really is for your particular use case, right? And one other thing to point out is that in the overwhelming majority of desktop deployments, random I/O is what we generally see. We don't see sequential I/O. So we do have performance issues around this, and we're going to get into that a lot more going forward, right? Okay, Jim.
So just to kind of give you an example to illustrate this, we put together a really relatively simple example of space and performance. So First of all, we just took an exemplar, RAID group and said 450 gig drives, 15K SAS drives, gives me about 1.25 terabytes of space. If I were to take, and again, this is linked clones we're talking about here, and put linked clones on this 1.25 terabytes, if I were using a 20 gig replica and I were using 5 gig or 10 gig linked clones, those are the numbers I would get. Now, we did this to make the math simple and to make the numbers not look so outrageous, but in reality, you're probably looking at 1 gig linked clones, maybe 2 gig linked clones, because you're going to refresh them over a period of time. We don't like to see them grow. So in reality, we could probably stick 1,000 VMs on this terabyte of space, potentially. Again, from a capacity standpoint only, So linked clones conserve a huge amount of space. You don't want that many VMs in a single data store because, as I'm going to show on the next slide, the IOP capacity isn't going to support them. So when we look at this, we're going to take that same RAID group, that same 1.25 terabytes, and just using rough numbers, I'm going to be able to deliver 1,080 IOPS from that RAID group. However, from a write IOPS standpoint, I'm only going to be able to deliver about 540 write IOPS because of the RAID penalty. This is just a simplified chart of what kind of I/O penalty we're going to pay with RAID. RAID 1, we're using RAID 10 here, which is really a striped RAID 1, so we're at a /2, so I've got going to be able to deliver about half of the write IOPS. And in general, desktops are more write intensive than read intensive. So you really have to pay attention to this. What I see a lot is, we're just going to take a RAID 5 group because it's easy to do, it's pretty popular, but now on RAID 5, we're dividing our write IOPS in a quarter. So RAID level is really important to keep in mind from a write standpoint. Write IOPS capability is dependent on my RAID level. And here's the kind of numbers we get. So what we did is we took some rule of thumb numbers, and we'll talk a little bit more about rules of thumb later, but a light user at 5 IOPS, a medium user at 10, a heavy user at 20. And we looked at a couple of different distributions. 50-50, so 1-to-1 read to write. 35-65, so about a 2-to-1 read to write, so 2 reads for every write, 2 writes for every read, and then about a 4-to-1. If you look at the numbers here, 88 VMs right in the middle of the chart, down to 33. So before, keep in mind, on this storage, I could pack 1,000 VMs on here potentially, but from a performance standpoint, I can't support anything near that. So just in general, we got a capacity for a large number of VMs, but we don't have performance for a large number. Anybody have any questions?
Can you repeat the question? I'm sorry.
In VMware View Architecture Design Guide, I thought it's the name, there was a number of 5 IOPS per 20 virtual machines. Those numbers are not correct in the guide.
So I think that what we'd say is, when we look at those types of numbers, we're really giving some general numbers, and what we'd say is, what we really would recommend is that you understand the specific numbers from your actual environment and then architect accordingly, right? The bottom line is, I always hear a number of, we can put 64 virtual machines in a data store, right, in a link clone environment. Well, if you don't have enough spindles, I'm not going to get anywhere near 64, right? If I have a good mix of, maybe it's all SSD, I can get more than 64. It really depends, and we need to understand that. And that's the point of this conversation is you really need to understand what the I/O requirements of your specific environment so that you can architect accordingly to deliver performance and design that back end to be efficient.
Yeah. So that may be correct for a given environment, and we'll illustrate this more when we talk about assessments. We see some very, very different numbers from environment to environment.
Yeah, but I think what he's trying to say is those are very low numbers, and what's going to happen is somebody's going to reference this document and give that to a customer and say, hey, we don't know what your numbers are yet, but we still have to make an estimate so we can allocate the purchase order for storage.
Yep.
But, 20 IOPS, that's usually the medium to light side of the house where you're looking at 25 to 50 minimum for a heavy type virtual machine.
So I see exactly what you're saying.
Without even antivirus on it,
Right. So I see what you're saying. You're saying that the numbers that we're listing here are conservative.
Very conservative.
Yep.
So that's fair, and we're going to talk specifically about that in a few slides.
Somebody
Yeah.
will take that literally, and they will give that to a customer, and they will start doing
we address that.
We address that in
Bear
a
with
later
us.
slide.
We do address that. Again, we're just using this for illustrations.
And this is what we see generally most of the time thrown around. But
Right.
we're definitely going to talk about that specifically. Yes, another question? There's no RAID penalty for read. The question was, does the RAID penalty apply equally for read and writes? And the answer is there is no penalty for read. The reason there's a write penalty is because if I'm going to do mirroring, I'm going to have to write that twice. That's why there's a write penalty. So I have 2 IOPS generated for a write if I'm mirroring, so RAID 1. If I'm doing RAID 5, the reason it's 4 times is because I have to do the parity information as well. So a write generates a lot more I/O than a read, because to read it, I just have to pull it once.
Okay, I'm going to keep rolling just because we're going to address some of the questions we're getting here. And again, I did say I'd be the question cop. Couple of things here, just some real-world examples that we've seen. So, talking to a customer, we're doing a POC, and hey, when we started the POC, we had great performance. Everything worked great, and now all of a sudden, users, it's taken them 3 to 5 minutes to log in. What's wrong? So I start talking to them and discovered that, when they started the POC, they had 10 users. Now they have 70 users. And we peel back the onion a little more and find out that, all those users are sitting on 3 SATA disks that are in a RAID 5 configuration. So, they're doing a whole roaming profile thing. We're getting heavy write IOPS. They're probably getting huge latency numbers. So yeah, the performance went downhill. Another thing that I saw from another customer, production assembly line, normal operations, and it's a 7x24 operation, everything's working great, no problems. And then they were using full clones, and when they'd go out to do an update, like a patch or a new piece of software, and they'd run these updates out, it would literally take them hours to get these updates run out. And they're looking at their physical environment and say, well, it takes 10 minutes to do it across, the same number of machines. What's the deal? Well, same deal. They didn't have enough IOs to just barely handle their production environment. And then they throw all these writes on top of it as they're putting out these massive software updates. And it's going to take a while because, again, those latency numbers are going to start to climb. And I just hit the wrong button. Another thing I hear often is, why do I need so many disks? We're wasting a lot of space. I have all these disks and I can only put so many machines on it. Again, I have to architect for performance. Size doesn't matter as much as performance. Again, maybe it matters a little. Performance is king. This is the thing that we've got to really design for, is performance, not capacity. So how do we understand desktop I/O requirements? What are some of the ways that we do this? To the points that a few people were trying to make here is, yeah, the rules of thumb are great, but how do we really get down to this? So how do you figure out what you need? No one's not going to have any idea about their current physical environment.
That guy
Yeah,
does.
that guy does, right. So, and one way you may know is maybe you just did an assessment. We're going to talk about assessments here, so you have a really good idea because you already have the empirical data. Again, on physical, you've got what you got. Those are the IOs you're going to deliver. You may have some users who have special IO needs, so you got them an SSD already, or they're running a RAID array, so you have some awareness of that. But in general, you got a disk in there, and you're the only one getting those IOs. Nobody else is sharing them with you. So how do we get usable numbers? Well, there's 3 ways of doing it. Rules of thumb, calculators, and assessments. So first, the rule of thumb. Okay, so this is one rule of thumb. Note the last statement here. You're going to find other rules of thumb and other guide numbers. That's why they're dangerous. Okay?
I got an example that I think will prove your point.
Yeah, great example.
So I got this example from the professional services organization that actually did deployment. Excuse me. But somebody looked at this rule of thumb, this specific one, and they said, I think where our users are going to be, excuse me, they're going to fall into that heavy category. So they said, we'll take that 20 and we'll double it to 40. And now we're being real conservative, so we're architecting conservatively, right? They had no idea what the actual number was, but they thought if we double heavy to 40, that should give us some headroom, right? So they go and they start scaling out their view environment, and they have performance problems. And they don't understand, why do we have performance problems? They start to look at it, and they come to realize that in their environment, the average IOPS per user was 100. It wasn't 20, it wasn't 40, it was 100. So they were way underestimating, so as they tried to scale out, it just didn't scale, right? So the idea here is we really need to have empirical data so that we do this correctly. These rules of thumb are dangerous, and that's to your point, right? So instead of using a rule of thumb of any sort, we really are better off to actually get real data.
Again, keep in mind these are average numbers. Don't forget that write-read mix. And when I say that, if I just look at that number and I see 20 IOPS, well, okay. But if I'm on a RAID 6 where I'm paying a /4 penalty and I'm heavy on writes and I don't know this, I could get myself in a lot of trouble. So again, don't forget the write-read mix. And the second point on this is don't forget the write-read mix. We really mean it. Just kind of, you got to keep that in mind. You need to do some planning or management for peaks. We're going to get to that. We've got a whole slide on how to deal with peaks. We're talking a lot about averages here. For a better picture, so we talked about rules of thumb, but for a better picture, use a calculator. It gives a better overall picture. Typically, we'll use rules of thumb numbers. Sometimes you can adjust the rules of thumb you're using, what numbers you're using. Great calculator, again, from Andre's site. This is just a screenshot that I stole from his website. Hopefully he doesn't mind. But this gives me a good idea of what I've got going on and allows me to at least get an idea of how many IOPS I really need to drive, so that instead of going to your storage team and saying, hey, I think I need about 500 gigs, you can say, hey, I need about 2,000 IOPS. And they may scratch their head, but this is where you have to have a conversation about this, because this is really important. Also, most of the storage vendors have a VDI-specific storage calculator that allows you to plug in numbers, maybe numbers that you've gathered from the assessment that we're about to talk in, and then we'll be able to spit out the exact disk configuration you need, how many disks of what type, and how you should architect it. So now we're going to go on to assessments.
Okay. So to the point here, now if we want to update our calculator and instead of using the rules of thumb that sit underneath the actual calculator and input our own information, where do we get that information, right? We've already determined that for the most part, people don't have an understanding of what the I/O requirements look like in their physical PC world, right? So there are partners, Lakeside Software, Liquidware Labs, probably several other we're not aware of.
Yeah, sorry if we didn't mention you if you do this. That's where the disclaimer slide comes into play.
So in any case, what these assessments do is they actually go out and look at the physical desktops that are in your environment. And then they get a lot of data, right? What we're focusing on here for our particular presentation is the I/O data that they collect, but they also collect information on which applications are in the environment, how frequently those applications are being accessed, memory requirements for specific applications, CPU. We're really focused on the I/O information that we can gain from doing one of these assessments, right? So a couple things. They can show us things such as times a day when peak I/O occurs, and again, in general, what we'd see is, if you're booting these things up in the morning, if you're doing antivirus updates at a specific time, backups, those things would show us spikes, but we can get a view into what that looks like, right? And then we can see potential areas like that we actually need to manage around, right? We can also see applications that are big I/O consumers so that we can understand the I/O workload from an application perspective, right? One of the big things that we really get from doing these assessments is this. If I look at all the physical desktops in my environment, I can now cherry pick use cases to do virtual desktops, right? So just like in the server world, when I started virtualizing servers years ago, we don't start with virtualizing SQL or Oracle or Exchange. We do the low-hanging fruit. So we get successful, we get comfortable with the technology. The same thing goes here, right? Let's not pick the AutoCAD users that are real finicky and start out with our first virtual desktop
Don't
deployment.
start with the cranky guy.
Find the use case that is going to make sure that you're successful with your first virtual desktop deployment, right? And identifying that use case can be done by doing one of these assessments, right? So there's a lot of value to doing these assessments. I guess that's the main point here, right? And when we talk about this, though, understand that the I/O information that we get from doing an assessment is kind of a worst case scenario. And the reason I say it's a worst case scenario is because I'm going to do image optimization before I virtualize those desktops, right? I'm not going to do a P2V of a physical desktop and then deploy it. I'm going to build a new desktop from scratch, and I'm going to do a lot of things to optimize that image to run in a virtual world, right? I'm going to turn off unnecessary services. Obviously, I don't need the wireless zero config service running on a virtual desktop, right? There's a lot of things, indexing, prefetching, defrag, so we can clean a lot of this up. So when we actually go to roll out these virtual desktops in the environment, we're going to see, we should see, less I/O than what the assessment even told us. But when we're architecting, the assessment gives us a really good starting point for where we're at in that physical environment.
We've actually got a Windows 7 optimization guide published, and it actually has a command script attached to it that you can just run, and we'll go through and turn off a lot of these unnecessary services.
It'll do all the optimization for you. Question? This partition alignment, we get to that. We had a little chunk on that. So when we get to that point, if we don't cover it in enough detail, let us know. Another question? Yeah? No, that optimization guide, the question is, did we write it or did Microsoft write it? This is a VMware document. A lot of it's from Microsoft best practices. But if you do a Google search for Windows 7 optimization guide, you'll find this VMware document. When you download it, it'll have, as Jim said, it'll have a text file attached. You rename it to .bat, and it uses PowerShell. And when you run it, it'll go through and do all of these things for you. Right? You can look at it and see what it's doing. But it's very, very useful, and it allows you to optimize that image very quickly without doing a lot of work and research on your side. Right? Other questions, or should we move forward? Okay. So Lakeside was kind enough to provide us with assessment data from 3 different assessments that they did, and we asked them to give us ones that varied so that we could show that there's a pretty wide variance between assessments in different environments, right? So the first one we're going to look at is this environment that had 4,400 desktops. This is what their I/O footprint looked like over the course of a week. We can see we obviously have some peaks that we're managing to here, right, at that particular time. But it also brings back this specific information, right? So what I'm going to focus on here is when we look at this and we look at the average, right, we see an average I/O per desktop of about 6 with a write-to-read ratio of 2 to 1, with twice as many writes as reads, and that's pretty normal, right? And if we look at the max, right, if we look at that max number, we're looking at about 38 IOPS, right? And incidentally, when we look at the write-to-read ratio, when we're looking at that at the max, it's the opposite. It's 3 to 1 on the read side, right? And why do you think that is? Because from a read perspective, when we do, Carrie, I appreciate the Lakeside stuff. So from a read perspective, bootstorms are going to be read information, right? So when we're doing a bootstorm and we're seeing all those reads, that's what's generating that max number and why it's so high, right? So really, when we look at this, even though that is a very small portion of the actual time, the big thing here is when we look at over as an average, we still are doing 2 to 1 on the right side, right? And the other thing I'd like to point out is even though we see a max here of about 166,000, if we look at just the 95th percentile, we're significantly lower than that, right? 62,000. So if we architected to this 95th percentile number, we could build this out at 14 IOPS per user and know that we're getting the overwhelming majority of our IOPS included, right? So we don't have to architect to this 38 IOPS to include the maximum that we saw. We can architect to something much lower. Does that make sense, guys? Okay. So another environment, 5,000 desktops. Again, pretty familiar pattern, right? I'm not going to get into this. I just want to show that in this particular one, look how low these averages are, right? 1.4 as an average and 4.2 as a max. This is an odd one in that it's about 50-50 read to write, right? And if we were going to even go to the 95th percentile, just such low numbers, right? So this is dramatically different from the last one we saw.
So this is a good example. If you use the rule of thumb, you'd have over-architected the environment. Even if you use the light user rule of thumb.
Right. And then this one's 3,000 desktops. And again, just to hit the high points here, an average of 5.5, max of 22. The write to read on this one is 3 to 1. And on this one, Just even on the Macs, it's heavy on the right side, right? So this is pretty typical of what you've seen. But the point of these assessment slides is basically that we really need to do this up front so we understand what that physical environment looks like, so we have a good starting point, right? And we're to the point where if a customer is trying to bring us in to assist with the proof of concept, we won't even engage with them until they've agreed to go through this process, right? Because it's a waste of time. If we're not going to take a look at what that physical environment looks like, we don't know that we're picking out a good use case where we can be successful and you can be successful. We don't know if we're going to architect the thing correctly so that we look bad. We want to make sure we do this before any type of virtual desktop deployment, right? So we can do this correctly. Any other comments here?
No.
Yes, question.
When you're doing the assessments, do you assess every single desktop or do you say, try to take a subset?
Okay, so the question is, do we assess all the desktops or do we pick a subset, right? So I think that that's really up to you as the customer, right? If you really have a target and you say, okay, I really want to just look at my call center desktops and you want to just do the call center desktops, and even there, let's say I have a call center that has 2,000 desktops, I could look at all 2,000 in that environment, or if I think that they're all so similar that I can look at 500 and get a pretty good idea, that's up to you. Or I can look at everything in my environment and then I have a ton of really good information. That's the other thing I'd say, is that if you do one of these assessments and it comes back and you decide not to move forward at this point in time with a virtual desktop environment, it's still really good information for you, right? This is fantastic information, right? And I think when you look at the tools and what they can provide, there's just a ton of value here, so I highly encourage everybody to go through this process.
Yeah, and two comments. We're focusing on the storage piece of this. This is like the tip of the iceberg of what the assessments do. There's a ton of information about applications and about sort of guiding you through what makes the most sense in use cases, what your consolidation ratios might look like. I mean, it's really a good tool. And to your question, from my perspective, I like to get a bigger look at the desktops. I mean, I've done some environments where, hey, we've got 5,000 desktops we might want to do, but we only want to look at 100. And I don't want to do that kind of an assessment. I'd rather look at a bigger swath of it because we might pick the wrong 100 and get just really bad skewed data.
And understand, right, when we're talking about this is third-party products. This isn't us trying to sell you something here. This is us trying to make sure that you're successful when you implement a virtual desktop environment, right? We get nothing by you guys looking at these types of solutions, right? Was there a question? Sure.
How does this convert over to RDS? If you have 1,000 users in RDS, they would want to put in view. How would you do something like this in RDS?
Yeah, and I don't have experience with that. The question is, he already has an existing environment with terminal services. So could you use an assessment tool to actually look at that terminal services environment and see how that would convert to a virtual desktop environment? And while I haven't done that, I believe that that's possible.
Go and talk
I see
to
head
Lakeside,
nodding from the Lakeside contingency,
Yep.
so that's a good thing.
So, yeah.
And do you guys do that a lot, Carrie?
Yeah,
Cool.
I thought so.
Okay. Okay, storage solutions. Jim?
Okay. So now we talked about the problem. We talked about how to get good numbers. Let's talk about some of the things that help solve the problems. So first, let's talk about the read side. All right. So you're probably wondering, why do these guys have an axe murder on there? So we're doing a read slide. This is a scene from Burn After Reading. So, all right, it's a stretch. We're from Minneapolis. The Coen brothers are from Minneapolis. So a lot of things help on the read side. So array-based cache is going to help tremendously on the read side, especially during those boot kind of operations, because a lot of that's going to be cached. In fact, when we did some of our testing with Ryan and DataLink, we actually did a test where we booted up a whole bunch of machines, and what we choked was the host, not the storage, because we happen to have the whole array to ourselves, and we had a 32 gig cache, and the whole image was less than 32 gigs. So, all of that was being, focused out of cache. So we got a lot of goodness from that. So, RAM-based cache, SSD-based cache, those are, the kinds of cache you're going to see from your array vendors. There's, from a couple of the array vendors, there's some of the branding of what you're going to see around, cache. Host-based cache is another thing. Talk to the guys from Fusion.io. They're putting a card in a cache. And again, we're not trying to sell a particular product, just giving you some examples of things that are out there. Future release of Vue, you'll see a content-based read cache that will actually be on the ESX host, which will help with this as well. That's something else coming down the road that will help with this as well, and something we can manage. Again, Vue Composer, we talked about this a bit. Again, referring you back, a shameless plug to our presentation from VMworld 2010 on Composer. One of the things we can do with this is we can do storage tiering. So we can take that base image of the linked clone, what we call the replica, and put it on high-speed drives, so SSD drives, and have a whole bunch of linked clones booting off of that. Now, we referred you to Andre's site. He just did some blog articles on this. This is going to help you a lot at boot time. Once we're off the boot, then all those reads and the writes are happening wherever you're storing the linked clones themselves, not necessarily where you're storing the replica. Did I speak correctly on that? Yeah. And so this really does help, especially at boot time. So we talked about boot storms, and we'll talk about it a little bit later, but this is one of those things that can kind of eliminate that because I've got a lot of IOs that I can drive out of SSD. Another thing is just to offload some things from the storage where you're storing your linked clones. So profile. I can take profile information. We've got View Virtual Profiles, which we've announced this week as part of View 5. The ability to, instead of using like a roaming profile where I'm doing a ton of reads at boot time, I'm just reading what I need from the virtual profile, so I'm eliminating some of that read. Using folder redirection. So the data is going to get redirected to the user's folder. Now I realize that there's still an I/O. You're still using I/O to do this, but that I/O is being taken off of where you're hosting the virtual desktops themselves and put someplace where you may already have it, because you may already have a CIF share. Somebody's got an H drive already. Another thing that can help here a lot is streaming applications in. Using something like ThinApp to stream applications in, instead of loading that application out of that linked clone, we're loading it from somewhere else. Again, we're offloading a lot of that read. All of these things, even though it's not on the next slide, which is the write slide, can help with write as well, particularly the profile stuff and the user data. With ThinApp, one of the things I do is I create a sandbox. So I take all of my application data and I write it. If I'm redirecting that up into my H drive as well, I'm offloading that from the linked clone as well. So again, I can help on the write side there as well. No RAID penalty. Somebody asked this before, so there's no read penalty with any RAID type. So no matter what RAID type you're using, you're not paying that read penalty. And it's hard to overrun the read IOPS capability because, again, we're building for write IOPS, and by and large, the write IOPS are going to be heavier than the read IOPS when it comes to a virtual desktop. Helping with write IOPS is a little trickier. There's a lot of stuff out there to help with reads. Some things that you're going to have to build out for the number of spindles. We mentioned these VDI calculators that a lot of the storage vendors have. That will help you a lot, especially if you've got good assessment data. Building out the proper number of spindles to handle your writes. So definitely talk to your storage vendors. It's a good time to engage them in this process. Don't forget the RAID type caveat. And again, we're going to say this 3 or 4 more times before the end of this. In fact, Jeff and I were kind of reviewing this before, and I'm like, we really hit that pretty hard, but it's really important. So just don't forget that. SSD writes are generally slower than reads. It can degrade over time, although we had a conversation with Mac Benesh, who does some of our reference architectures, and what he's seeing based on their testing is they figure about 6.2 years for SSD drives for at least enterprise quality. So if your refresh cycle is within that, you probably don't have to worry about this quite as much.
And that was specifically around virtual desktop workloads, right?
Correct.
So before everybody says, okay, I'm going to get 6 years. His point was what they're finding is it's a lot less of a hit in a virtual desktop environment on writes with SSD than we assumed. So we're going to get more life out of that SSD than we had taken for granted.
Yep. There's some vendor solutions that may help with this. You'll see things like Fast at Rest, Waffle are some examples there. There's also vendors who do dedupe. So they'll have a virtual appliance, so they'll do dedupe and then take all those random IOs and serialize them. Their claims are to reduce IOPS, write IOPS by about 90%. I'll let you talk to the vendors out on the storage floor and get some ideas from that. I'm not here necessarily to plug a specific product. Again, this is where the disclaimer slide applies. Again, sizing for write IOPS is probably your most critical area. Really be looking at that. And again, that assessment data is going to help you a lot with that. And work with your storage vendor, which we talked about already. One solution I wanted to talk about that we've introduced with vSphere 5 is the VSA, the virtual storage appliance. So what this allows me to do is take virtual machines and turn them into a virtual storage appliance. The architecture is either for a 2 or 3 node cluster, at least for this initial release. You're either going to have 2 servers or 3 servers. You're going to take local disk and put it in a RAID 10 array, and then half of that is going to be available as primary storage, and the other half, as the sort of blue lines are showing here, is going to be used for replication between the nodes, so completely fault-tolerant solution. There's a couple of things you need to keep in mind here. This is primarily probably an SMB type of a play, and what happens is each one of those hosts, we're showing 3 here, but it could be 2, is going to export a shareable NFS data store. So I can do vMotions, I can do DRS, I can use it. Really great solution for a robo-type solution or a small business-type solution. Available with vSphere 5. Keep a careful eye on the write IOPS numbers again. So 2 things here. Using RAID 10, so we're at divided by 2 at that point. Plus, we've got to take the replication into account because we're going to use some write IOPS for that replication between the nodes. So you just got to make sure you size the number of desktops correctly. Understand the configuration and HCL limitations or specific HCL with this initial release, and really sort of a robo or SMB solution.
I got a question for you. Now, on the VSA, is that being done synchronously, the replication, or
Yes.
is it done asynchronously?
Yes. Yeah, synchronously.
And so, in synchronous replication, you have to wait for the acknowledgement back from the other node before you can send.
Yeah, but you've got a dedicated link in place, and this is a within data center kind of solution, so it's going to be very rapid.
So we're talking about this specifically because we're with all of the announcements around vSphere 5 and all the conversations around vSphere 5. We know that people are going to look at this as one option for virtual desktops because it is shared storage, right? But I think what we'd really stress here is that while you could do virtual desktops off this type of an architecture, there's a lot of caveats here, and we would stress that you should be very, very careful, and you got to be careful in general. But because of some of the limitations that Jim outlined, would be very conservative with this approach. And again, if it's a remote location, you just need to spin up, several desktops for whatever they need in that remote location. That's fine, but be careful.
Yeah, just don't fall until we got plenty of space trap. That's sort of what we're saying here. Jeff?
Oh. Okay, so dealing with the peaks, right? And when we looked at that assessment information, we did see a lot of spikes and a lot of peaks. And I think we've hit on some of this already, so I'm not going to spend a lot of time. But boot storms, right? How do we deal with boot storms in the environment? As Jim mentioned in our testing with DataLink on their NetApp arrays, we saw that just caching in itself could really alleviate a lot of this problem. The tiered storage solution, where we put that read-only parent partition, right, the replica on SSD, that can really alleviate this problem. There's a lot of things we can do. Another thing we haven't mentioned, but we can set a policy when we create that view pool to leave those machines on all the time, right, so we don't have to worry about them booting up. So there's a lot of things we can do to help overcome those types of spikes. Antivirus. This is also critical. We've talked about this a little bit, right? But from an antivirus perspective, even on an individual PC, once my antivirus software kicks in, I notice a performance hit, right? Now, if I take and scale out a virtual desktop environment and that antivirus scan hits all of them at the same time, it'll bring that environment to its knees, right? It's a huge, huge performance inhibitor, right? So keep in mind that a lot of the antivirus vendors now understand the implications of antivirus in this type of an environment, and they've built in functionality to overcome some of these limitations. So what they'll do is stagger scans, so they're not scanning everything all at the same time. They can have a virtual appliance where the virtual appliance will recognize files that they've already scanned. So once they've seen it and they mark it, if they see it over and over again, because all of these environments are, all those machines are so similar that they won't scan it again. So we can offload a lot of that and overcome a lot of these challenges, right? vShield Endpoint really enables that technology for our antivirus partners that are doing that, specifically with DAT file updates, right? So if I can remove those antivirus agents from all of those virtual desktops and just have a single virtual appliance to do that antivirus on each host, instead of pushing DAT file updates to 1,000 virtual desktops, I just push it out to that single virtual appliance on each host. So that really alleviates a lot of the overhead of the antivirus solution, right? Login, right? This is another space where we really see a lot of I/O. If you have everybody logging in at the same time, we've talked about this already. right? If we're going to use some type of virtual profile solution, right? View 5 is going to ship our virtual profile solution, but there's also, AppSense, RES, Liquidware. There's other solutions out there. But if I'm streaming the pieces of the profile that I need in real time instead of pulling down an entire profile, obviously that's much, much more efficient. So that can really help. Leaving users logged in. So that's another option, right? Especially if I think of kiosk mode where the user's logged in all the time. But another thing is, just like in the physical world, if I'm going to walk away and I do Control-Alt-Delete, I'm leaving my user logged in, and then I can go to another device, and View will automatically connect me back to that desktop, so I don't have to worry about logging in and having all that overhead on the system. Question?
Is there any thought to building in an option in Composer to schedule the power-up of VMs? So, if you know you're going to shut down at 5, you can shut down your VMs, and then maybe at 6:30 you can start booting them up ahead of the 8 o'clock time when users are in it.
So
Levin
Chang is up here as one of our product managers. He's nodding his head here, so I'll let him answer that.
Yeah, we can take it offline, but in the future release is on a roadmap item, and it exactly address that issue.
Okay, and we do get that a lot, right? Yep. So it's good to hear it's coming because that's a pretty common request. Okay, image optimization. We've talked about this at some length already, right? But obviously if we have an optimized image, we can offload a lot of that. From an operational perspective, if we can do builds, updates, and disk operations, and again, if you're not familiar with Composer, this is refresh, rebalance, recompose, right? If we're going to do these Composer operations, if we can schedule them to happen in off hours, that really, really helps, right? If you are 24/7 shop and you can't afford it to do, there is no off hours, right? At that point, you can throttle the number of concurrent updates just to make sure that you don't have it happening all at once, right? Okay.
That's me. So, latency is generally the best indicator of a problem. So we had a few people who were very helpful with us, and we ran this by one of our local NetApp resources, and he said, I want to get a T-shirt with this on it, because he runs into this all the time. Understanding your latency baseline and having a monitoring tool, really important. So earlier when I talked about that POC environment where they just kind of ran out of gas, if they had understood their latency baseline at the beginning, were monitoring that, they would at least have known where they sort of tipped over. 20 milliseconds of latency seems to be a magic number for a lot of the storage people we talk to. You may have a different number. It's just general rules here. 50 milliseconds is going to look like really bad, and I've actually seen this at customers, and then anything bigger than that, which is potentially possible if you don't do some of the tips that we talked about, it's just going to look like a service outage. It's just not going to be good. Keep an eye on your baseline numbers as you add desktops. So again, get that baseline, see where things are going. If you're starting to get to a point where you're starting to get high latencies, well, then either stop adding to that particular data store or do something to add more I/O capability to that data store. It might be adding another cache card to your array or whatever. There's a lot of solutions out there for that. Just a sort of a side note here. If you're not doing refreshes on a regular basis, don't use link clones. It can actually cause you a read penalty over time. I actually ran into a couple customers doing this. We're using link clones, but we never refresh. Performance is getting worse. Over time, that can happen. And again, the space is probably not going to be a problem. I think we've already illustrated that, so there's no huge advantage to using link clones if you're not going to actually use link clones for what they were intended to be used for. So disk alignment. Somebody asked this about this before. So this is just making sure that VMFS is lined up with your data store and that your Windows partitions are lined up with VMFS, so that you're not have this sort of interleaved alignment, which will cause you, up to a 50% performance hit on top of your RAID performance hit already. Windows 7 is going to be aligned automatically, or older operating systems won't. If you create VMFS from vCenter or the vSphere client, it's going to be aligned properly. And you can always check with manually just to make sure. This is really important. We actually have a reference to a blog article on this that we thought was a pretty decent blog article at the end of the presentation. We got a lot of really major content here, so we just want to make sure you guys are still with us. So we're also featuring the only yak at a VMworld presentation this year.
And that picture is a good insight into Jim's sense of humor, for better or worse, right? Take that for what it's worth. Okay, so we've hit on this. Again, I'm not going to talk about this much. Be aware of the RAID choice. One thing to consider is RAID 0. And again, most people don't consider RAID 0 specifically because if you have a single drive failure, you lose data, right?
Yeah, it shouldn't even be called RAID because there's really no redundant element to it.
But in any case, if you wanted to implement RAID 0 because it's truly floating desktops and you've broken apart all the critical pieces and the user can connect back and connect to a desktop in another pool or the same pool on another host with another data store, they'd get back to their environment very quickly, but there would be a disruption there. But if you're really I/O constrained and you want to get some of those write I/Os back, you can eliminate that write penalty by implementing RAID 0, right? Don't worry about wasted space. And again, I think that we've hammered on this over and over. You're going to look at these data stores that have, especially the desktop team that's managing View. When they look in View, they're going to see data stores that have enormous amounts of space in them, and they're going to think, why can't I just build more desktops in this data store? It's huge, right? It's got so much free space. But again, if there's not enough spindles sitting underneath it to deliver the I/O required by those desktops, there's going to be a magic number, and hopefully you know that number. And hopefully once you know that number, you take that into account and you don't go over that number when you're building this out.
And
right?
we do recognize there are technologies that will thin provision the data store so that it won't appear that there's all that used space too. So
yeah, and the analogy here is just because you still have check blanks left doesn't necessarily mean you have money, right? So CapEx cost per I/O, right? So again, there was a great blog posting by Scott Lowe on this topic, and it's in the reference section. But he really does a good job of illustrating how to take into consideration looking at 15K drives and their cost point on the price per IOP, looking at 10K drives, and from an OpEx perspective as well, and then choosing the right technology there. And that will probably fall more to your storage team, but definitely something to consider, right? NFS versus block. Again, I think that 4 years ago when I started VMware, we saw probably 90%, 95% of implementations were all on VMFS, on Fiber Channel specifically. That's changed dramatically. We see a lot of NFS out there. With the release of vSphere 5, we now have vStorage API for array integration support for NFS. I would say that there should be absolutely no difference between the two different types. I don't think that this is even a conversation we need to have.
yeah, and we don't want to have a religious debate. So I mean, it's there's a lot of parity now between those two technologies.
Okay.
Okay. All right. So getting down to the summary here. Well-architected performance equals a successful implementation. Again, I think we've hammered this home pretty well. You want to make sure that you've architected things properly. Involve your partners. So your storage vendor, PSO-type partners. Involve your internal storage team. Have a conversation around this. Don't just say, I need 400 gigs of storage. Again, do an assessment. Get over the wasted space. See the first bullet. The really great way to know, the only true way to know what the IOPS are going to look like is to pilot the environment. Measure it again. Use those same tools used for the assessment and really zero in on what things are. Going to take questions now, but I just want to put up this resources slide here for a sec. A lot of people like to take pictures of these. And again, you'll be able to download these decks from VMworld.com.
So everybody, I notice everybody's rushing for the exits, but we would really appreciate if you could actually go and fill out the survey. Hopefully you got some value out of the content here. We tried bring back information from what we've seen from actual customer sites, and hopefully this is good information. And if it is, the only way Jim and I get to come is if you guys actually say that we did a good job. So if you didn't think there was value here, then ignore what I just said.
Please keep that to yourself. But thank you for your time. And again, if you have questions, just come on up and we'll hang out. Thanks a lot.